Science may seem like magic because it can make the impossible possible. In this video, we will do some really cool experiments to learn how to levitate objects using magnetic force. Let's first understand what magnetic levitation is. Magnetic means something related to magnetism or attraction and repulsion properties of magnets. Levitation means causing something to rise or hover in air. So, magnetic levitation is a method where an object is suspended in air using magnetic field alone. True magnetic levitation is an advanced concept and can be achieved using electromagnets and superconductors. However, in our experiments, we will use simple magnets and a mechanical constraint to levitate things. To achieve levitation, we need to address two primary issues: lifting force and maintaining stability of system. Lifting forces, sufficient to lift the object upward to counteract gravity, are supplied using a magnet by harnessing the properties of attraction and repulsion. Each magnet has a north and south pole. Bar magnets have the poles on their two ends, and ring or round magnets have poles on their sides. Unlike poles of two different magnets attract each other, and like poles repel. We will use this property of magnets to achieve levitation. Stability of system ensures that the system does not spontaneously slide or flip into a configuration where this lifting force is neutralized. You see, here I am trying to keep these two magnets like poles towards each other. I am doing this forcefully, and the moment my grip is loose, the magnet would flip to the other direction to be in a stable configuration. I will discuss both of these factors in detail during our experiments. Let's now do some real magic. For this experiment, we will attach a small magnet to the top end of a pencil using tape, like this. Now we need to make a stand for this pencil, something like a desk lamp. I will use Legos to make this stand. First, make a base and a tower with height slightly more than that of the pencil's length. Then we will attach a magnet to the top of the stand. It should be properly aligned with the base where we would keep the pencil. This magnet should be placed that if we put the pencil on the base, then the unlike poles should face each other. Then start adjusting the height of the base so that you feel a strong force of attraction between the two magnets. Strong enough to keep the pencils standing upright without sticking to each other. If we move the pencil a little more up, then it would just stick to the hand of the stand. The lifting force is provided using the force of attraction between the two magnets, whereas stability is provided by keeping the base height such that they attract each other without sticking to each other. One tip: as you sharpen the pencil, you can adjust the height of the tower or base to keep your pencil in place. For this experiment, we need to make some kind of a bridge. I have used books and a ruler, but you can use anything. Then stick a strong magnet over the bridge. Take a thin thread and tie it to a paper clip at one end. Now we will slowly lift the paper clip towards the magnet until it is suspended in the air. You will just feel when the magnet starts attracting the paper clip, even when it is a little away from the magnet. At this point, tape the other end of the thread to the floor or tie it to a heavy load. I have tied the string using Lego blocks so that they don't move. Also, I have attached a rocket sticker to the clip. and a paper clip is suspended in the air against gravity. The lifting force here is supplied using the force of attraction between the magnet and paper clip, whereas stability is provided by using appropriate length of the thread, just enough to let it enter the magnetic field of the magnet without touching it. Let's see what happens if I loosen the thread. The paper clip would just stick to the magnet and the experiment won't work. For this experiment, I am using two very powerful ring magnets. Be careful while using powerful magnets because in certain configurations, you might pinch your fingers between two magnets or the magnet might slide to be in a stable configuration and may cause injury. Tie a magnet to the cardboard base using two strong threads such that the length is just enough to keep the magnet in the center of the cardboard. Now put another magnet under this such that the like poles face each other. Adjust the bottom magnet such that the top magnet starts levitating. While doing the adjustments, move the bottom magnet in between the two threads. And our levitating magnet is ready. In this arrangement, lifting force is provided by repulsion between these magnets, and we have tied this magnet to make sure that it does not move out of this configuration. Try placing objects of varying weights on a levitating magnet to see how much it can hold while still levitating. For this experiment, we would need a pencil, 10 ring magnets, an ice cream stick, and a piece of styrofoam or thermocol. Make 4 slits in a thermocol like this to hold our magnets. Make another slit slightly ahead of these slits in the center. Insert an ice cream stick in it. Take a pencil and put 2 ring magnets around it. Place the pencil in between the slits with the tip touching this ice cream stick. Adjust the magnets of the pencil such that the rear magnet is in phase with the rear slits. And the front magnet is slightly ahead of the front slits. You may have to wrap some sticky tape over the pencil under the magnet so that it does not slip out of its position. We make pairs out of 8 magnets and put each pair in these slits such that the bottom magnets repel the top magnets. We could put just single magnets in the slits. However, by joining 2 magnets, we would get even more levitation. Keep the pencil above the bottom magnets in the center while touching the ice cream stick. Enjoy your pencil hovering in air. Wondering how this works? Here, the lifting forces are provided by keeping top and bottom magnets such that they repel. 2 round magnets in a plane with unlike poles in the same side would attract each other. If they are placed with like poles in the same side, they will repel. While repelling, one of them would tend to slide forward or backward out of phase so that their unlike poles face each other and they stick. If we do not use ice cream stick and keep the bottom and top magnets in the same plane, the pencil would either move to the front or back so that the unlike poles touch each other. However, when we move pencil's front magnet slightly ahead of the bottom magnet, the pencil could only attain stability by moving forward, where we have already put an ice cream stick to restrict it, so it stays in levitating position. Take a stick and put it in a piece of thermocol. Slide a ring magnet onto the stick. It will fall down. Slide another ring magnet onto the stick such that the like poles of both magnets face each other. This way they will repel each other. Repeat this with more magnets. We just built a tower of levitating magnets which behaves like a spring. Levitation is achieved by using repulsion property of magnets, and this stick is used to restrict these magnets from sliding out of this configuration. Magnets are fun. If you enjoyed watching this video, you will enjoy doing these experiments even more. Like this video and share with your friends. If you are new to my channel, do subscribe for more such informational videos.